Hello, this is Will Robertson of the Aerospace Education Services Project for Summer of Innovation. Let me introduce you to the Waves and Optics unit. This unit is comprised of 3 lessons, each with various activities. A closer look at the activities in Lesson 2 on manipulating waves. It is actually made up of 5 activities: manipulating electromagnetic waves, constructing a spectroscope, simple magnifiers, and space operations learning centers. Simple magnifiers will be a fun and an eye-opening way to interest students in understanding waves and optics, since magnifiers are so prevalent in everyday usage. For example, many people wear glasses every day to be able to read and focus on what is around them. This activity actually integrates a series of investigations that are designed to demonstrate methods of manipulating waves and applications of those concepts. The object of this activity is to have students demonstrate how water drops in various bottles and lenses manipulate light waves to magnify letters and numbers. Some key terms students will be able to discuss include what exactly is a magnifier, light waves, concave lenses, convex lenses, refraction, and reflection. The lesson plan goes to the activity worksheet with the provided link. For the simple magnifiers activity, 3 details should be emphasized: equipment necessary, possible expense, and safety issues. The materials needed for this activity can be found in most homes. Students can be asked ahead of time to bring in enough materials so that all the students can inexpensively enjoy them for classroom use. Safety issues include care with glass materials that may break. Let's start with the first procedure. Make a simple magnifier with just a drop of water over a transparent tape frame. You can also use a piece of clear plastic lid. Position a drop of water over a magazine story or newspaper writing. Experiment by using a big drop of water and then a small drop of water. Do you see a difference? There are various forms of magnification in most science rooms. For example, a magnifying glass which uses a convex lens to make things look bigger by allowing the user to hold them closer to the eye. A telescope uses a large objective lens to create an image of a distant object and then allows us to examine the image closely with a smaller eyepiece lens, making the object look bigger. A microscope makes a small object appear as a much larger object at a comfortable distance for viewing. A microscope is similar to a telescope except that the object being viewed is close to the objective, which is usually much smaller than the eyepiece. A projector makes a large image of a small transparency on the screen. You can demonstrate, or better yet, have the students use these objects to demonstrate the similarities and differences. The earliest evidence of a magnifying device dates back to 424 BC. This lens was actually a glass globe filled with water. This was followed by the development of eyeglasses in 13th century Italy. A fun extension is to have students observe a penny with a drop of water and other magnifiers. Students are surprised to see the statue of President Lincoln sitting inside the Lincoln Memorial. Students may want to know how their eyes focus or that the human eye has a lens. On the back of your eye is a complex layer of cells known as the retina. The retina reacts to light and conveys the information to the brain. The brain in turn translates all that activity into an image. Because the eye is a sphere, the surface of the retina is curved. When you look at something, 3 things must happen. The image must be reduced in size to fit onto the retina. The scatter light must come together, that is, it must focus at the surface of the retina. And 3, the image must be curved to match the curve of the retina. To do all that, the human eye has a lens between the retina and the pupil, or opening at the center of the eye that allows light into the back of the eye and a transparent covering, or cornea. The lens and the cornea work together to focus the image onto the retina. Students can make emphasis on how the human eye lens and the water or glass lens is similar and how they are different. Magnifiers bend light rays. Concave surfaces curve inward, convex surfaces bulges outward, and concave lenses cause light rays to spread apart or diverge. Convex lens causes light rays to meet or converge. You may want to have your students research applications of magnifiers to NASA and our space program. Your students may have heard of Edwin Hubble, who was an American astronomer that profoundly changed the understanding of the universe by confirming the existence of galaxies other than our own, the Milky Way. The Hubble Space Telescope, named after Edwin Hubble, has helped scientists determine the process of how planets are born and many other discoveries. You can also access the beautiful images sent to Earth from Hubble at hubble.nasa.gov. Here, astronaut Dan Tanney, recently aboard the International Space Station as a member of Expedition 16, has taken nighttime photographs with a resolution of better than 10 meters, about the length of a bus, using a 400mm lens. Another example of how magnifiers aid our understanding of space is the MALI. The MALI, or Mars Hand Lens Imager, acquires close-up images of materials on the Martian surface. Well, thank you for joining me today, and I hope you and your students will enjoy learning about simple magnifiers.